Hello friends, welcome back. Have you tried generating normal density distribution curve in Excel? Did you know it is very easy to generate normal density distribution curve in Excel? You know what? I'm going to right here, demonstrate live to you how to generate normal density distribution curve. Taking only 2 columns in Excel. Yes, 2 columns. Let's do it. As you can see, now I have opened blank Excel workbook. So I need, like I mentioned, 2 columns A and B for this demo. In column A, I'm going to call variable, let's say, as X, and in column B, I'm going to have a function of X. This is a simple way to think about it. Let me just do some alignment here. So hope you all can see this. Let me just zoom it a bit. X and f of x, column A is X and column B is f of x. Actually, what I'm plotting is the standard normal distribution, and therefore column A is actually the z values of the z-scores, and the column B is what's called probability density function, abbreviated as PDF. So I need to generate some data for column A or for some z-scores, therefore I can calculate the probability density function. How I'm going to do is something like this. I'm going to start with -3, so I'm going to generate the data from -3 to +3. So what I'll do, I'll start from -3 for Z and then increment it by 0.1. So it becomes -2.9, and I shall select these 2 cells and then generate data all the way up to +3 starting from -3. Well, allow a few more seconds. There you go. I have overshot my generation of the data, so I shall get rid of few values that I don't need. Here is something to think about. Why did I choose the values from -3 to +3 instead of any arbitrary data, or instead of choosing values from, let's say, -infinity to +infinity? If you know the answers, please pause the video, think about it, and then comment in the comment section down below. Looking forward to some interesting and thoughtful answers in the comment section. So now the second column B is of importance to us. I'm going to look at probability density function. In fact, I'm going to generate standard normal distribution in Excel, isn't it? So I'll say how to invoke a function in Excel. All of you would know. Put equal to in a cell and it will invoke a function. Since I want to generate normal distribution, so I'll start typing few letters NORM, and you can see it pops up a lot of options like norm.dist, norm.in, norm.s.dist, etc., etc. What I'm interested in, standard normal distribution, and therefore I select the third option. So I'm going to click on that, and you can see it says that it returns the standard normal distribution, which has mean 0 and standard deviation 1. Remember, any numeric variable can be transformed into its standard normal distribution by taking it through what is called z-score transformation. I hope you recollect that. So I'm going to select this function norm.s.dist. It will ask me for the first parameter Z, that is nothing but my column A, and I'm going to select the value -3, that is in the cell A3, and put a comma. Then the second option is to specify whether I need cumulative probability or not. If I say true, it will give me cumulative distribution function, and if I say false, it will give me probability density function. As you are aware, I have named the column B as PDF, so I'm not looking at the cumulative distribution function. I would need probability density function, so I'll select non-cumulative as the option. So how do I do that? I can select false, or I can also say 0, close the parenthesis, enter. Voila, it populated the probability density function values for -3. So all I'm going to do is select this cell and then double click at the corner here and then populate the rest of the column for column B, that is probability density function. Now the data generation part is clear, and I've got all of this sorted. Hope you are clear about how did I generate the data. So all I have to do is select these 2 columns and go all the way down to select the entire column along with the data, and go to Insert tab in Excel and select appropriate chart for viewing this, and I'm going to select the option that is generating normal distribution. Voila, lo and behold, you have the standard normal distribution right in front of you, friends. So there is this vertical column, so I'm going to get rid of it. It is not required, so that I'll make it little neat and tidy. Yes, now we have a beautiful distribution function, if you can think of it as standard normal probability distribution function. Probability distribution rather. What you have on the x-axis are the z-scores, which ranges from -3 to +3, and what you have on the y-axis is the PDF itself. So let's go ahead and create some meaningful plots. So I'm going to have axis title, and I'm going to have the chart title also. So chart title, you can rename it as standard normal distribution function, if you want to name it like that, for example. And on the x-axis, you can say z values or z scores. And of course, as you know, on the y-axis, we have, okay, I'm not able to select this. Let me just do this. On the y-axis, you can simply say PDF. Voila. This is standard normal distribution. Okay. So remember, applying standard normal distribution to any numeric variable makes mean 0 and standard deviation is equal to 1. This is achieved by applying z-score or z-score transformation. Another important thing to note, if you know what is called empirical rule, hope some of you recollect, it states that 99.87% of the distribution of the data for a numeric variable will be contained in ±3 standard deviations. That essentially means anything less than -3 standard deviations, anything beyond +3 standard deviations will be unusual data. Typically, we interpret them as outliers if the data follows normal distribution particularly, and that data occurring is very less in terms of the frequency of occurrence. So maximum number of observations will be within 99.87%, that is distributed between ±3 sigma. We call that as containment. And what I'm talking about is what's called popularly empirical rule. So this is how you look at creating a standard normal distribution in Excel. Hope you enjoyed this video and this demo. If so, give it a big fat thumbs up. Those of you who would want me to provide you with bite-sized content like this, where you can see live the data coming to life through very intuitive implementations and walkthroughs, please let me know what I should create the content for you next. And friends, consider subscribing to my YouTube channel. This is Manjunath signing off. Thanks for watching. Take care. Bye-bye.